To continue our discussion on experiments today, we're going to go back to some vocabulary and define some important words that you may or may not have heard before. So the first is placebo. A placebo is a fake treatment. Thinking like sugar pill. Placebos are a great thing to use in experiments. In our experiment, I did actually set it up to use a placebo. So back in the beginning, I had said I wanted to come back and explain my choice here. When I was assigning my levels, my two possibilities, I did Pepsi and I did caffeine-free Pepsi. I could have done Pepsi, that's caffeine, and given the second group nothing. Nothing. That's equivalent to giving them 0 caffeine, but instead I chose to give them caffeine-free Pepsi. That's because this caffeine-free Pepsi is a placebo. It's a fake. It's like Pepsi. It looks like Pepsi. It hopefully smells like Pepsi. It may or may not taste like Pepsi, but it's the same thing, but without the caffeine. So it is a fake. So my caffeine-free Pepsi was a fake. We give placebos because the placebo effect really exists. Okay, this thing is real. People react differently only because they get a treatment. Now, they have done experiments to prove this. If you give people a sugar pill, there's no medicine in it. It's only sugar. They will actually feel better, simply because a doctor gave them something. Think about a 2 or 3 or 4-year-old that you know. I have a little niece who is, oh goodness, she's 3 now. And if she falls down, she wants a Band-Aid. Now, does she actually have a scrape? No. She just wants a Band-Aid because then she's getting something and she feels better. When she was 2, she didn't want a Band-Aid. She just wanted a kiss. Right? You've seen that. A little kid comes over, oh, Mama, kiss it better. Is there something medicinal in saliva from a kiss? I don't think so. It's simply that belief. The child believes, oh, if Mommy kisses my little owie, I will feel better. That's the placebo effect. It really exists. So if I gave one group Pepsi, right, here's my 2 groups. If I gave one group Pepsi and the other group I gave nothing, this group might have their heart rate go up simply because they are drinking something. Maybe it's not the caffeine at all. Maybe it's simply the act of holding a cup. Maybe it's the act of, swishing it down your throat. I don't know. So it's not really fair to give one group nothing. Instead, I give them a placebo, so that everything else is the same. They both get a cup, they're both swallowing, they're both drinking, just one has the caffeine and one does not. All right, so these 2 ideas definitely go together. The next 3 terms go together. Blinding, no, we're not poking out anybody's eyeballs. This is where people involved do not know which treatment they're getting. While I was talking about the Pepsi and caffeine-free Pepsi, some of you might be thinking, yeah, but I know I'm getting caffeine-free, so what's the point? Well, we want to combine that with this idea of blinding. I come in and I give out paper cups. And you don't get a can that says Pepsi. You don't get a can that says caffeine-free Pepsi. You just get a paper cup. You don't know which one you're getting. Okay, some of you might be able to taste the difference. But again, this is just for example. So we don't want the people involved to know which treatment is being given out. So single blind, this is where the subjects don't know. So the people drinking the Pepsi and the caffeine-free Pepsi do not know which one they got. Double blind, give myself just a little bit more space, the subjects don't know. And since it's double blind, there's another group. And I will call those the evaluators. don't know. So for reference, this is the people drinking the soda. The evaluators would be the ones who come in to check on my response variable. I might hire a whole bunch of nurses to come in and measure your heart rate. Those would be the evaluators. Measure heart rate. It's not fair if they come in and they say, oh, well, Bob here, he got the caffeine, so his heart rate should be higher. They might not count accurately. Something to watch out for with these ideas, double blind does not mean nobody knows. Someone has to know. Okay, so there's someone, I don't know, sitting behind the two-way mirror who can say, yep, those 25 people, they have the caffeine. When I get their results back, I know they had that caffeine. So this is usually the person in charge of the experiment who's going to write the final paper, do the final analysis. Someone has to know. All right, let's move on to just a couple more important ideas for this chapter. What if we were interested in two variables? What if I wanted to throw candy into the mix to see if that increases your heart rate? So now I have two factors, right? These are both factors. Remember, those are our variables. That means I now have some combinations I could make. And we call those combinations treatments. I could do candy and the Pepsi. I could do candy and the caffeine-free Pepsi. I could give no candy with Pepsi. I could give no candy with the caffeine-free Pepsi. So that's what I mean by combinations. Okay? Treatments is where I put them all together. So if I wanted to draw that in a diagram, there's a couple different ways I could do that. I might, 50 does not go into 4 very well, so let's say that this time I have 40 students. I might draw it this way. Here's my students who are getting the Pepsi. Here's my students who are getting caffeine-free. Remember, we're going to randomize here. So I give 20 Pepsi, 20 caffeine-free. And then within that Pepsi group, I might split it with candy, no candy. And in my caffeine-free, I do the same thing. Some get candy, some get no candy. And then when I'm all done, again, I'm going to compare heart rates. And yes, in case you're wondering, these should still be assigned randomly. So again, that's just one way to visualize this idea of adding in another variable. All right, so the last thing I'd like to mention today is principle number 4. Okay, just to remind you, I did say that there were 4 principles of good experimental design, but I only talked about 3. Control, where we keep things the same. Anything other than the variable we're testing, we try to keep the same. We randomize, put names in a hat, draw them out to decide who gets what. And we replicate. We use more than one person. The 4th principle is called blocking. And this principle is not required in every experiment. It's a good one, but it's not always practical, not always necessary. In blocking, we group similar individuals together. That's because there are some characteristics that we're not studying, but we can't control them. An example would be gender. Okay, I'm not studying gender in my experiment, but I can't control it. I can't say, oh, well, magically everyone today will be male. Okay, I can't do that. So instead, I'm going to do what's called blocking. I'm going to put the genders into groups based on a similarity. So for example, let's go back to the situation where we just had caffeine, Pepsi and caffeine-free Pepsi. So I have my 50 students, and the first thing I'm going to do is block them by gender. Okay, so I'm going to block here. All the males I'm going to put together and all the females I'm going to put together. They might not be even. I might have 30 males and 20 females. That's okay, but I'm going to split them up. Because you know what? Maybe males react to caffeine differently than females. I can't control that, so instead I'm just going to separate them so I can see the difference. Then I'm going to take my males and I'm going to randomly assign half of them to Pepsi and half of them to the caffeine-free. And I'll do the same with my females. I will randomly assign half of them to Pepsi and half of them to the caffeine-free Pepsi. And then I'm going to compare their heart rates. So notice what I did, what makes this blocking, is that I split apart males and females. They were grouped together based on similarities because I'm not sure if males and females will react to caffeine differently. So again, that's our last principle called blocking. And that concludes all of our big vocabulary ideas for experiments.